Glad everybody braved our winter weather here. We're officially in the second half of May as of today, officially in the second half of May today, and we got rain. So for Californians, that's an exciting thing. I guess if you were sitting on the freeway this morning trying to get here, you probably didn't think so, but we're happy. I was sitting there watching John and Rod's talks, and I was pleasantly struck at the alignment between some of our graphs. So I don't know if I stole his or he stole mine. I'm going to talk a little bit today about what we're doing at Southern California Edison. We're a local utility, but we're a big utility. Many of you know that California tends to lead the country in these kinds of efforts towards sustainability. And as publicly regulated investor-owned utilities, we really get a lot of push to do that. It's part of our business model. And as a result, we have the opportunity to do a lot of things that other utilities or other companies across the country don't. So it's pretty exciting to be in the kind of work that we do. We have a natural combination of all of the kinds of topics that you heard in the first two talks today. And in fact, as I was sitting there listening, I was scribbling notes, and I noted about 14 different technology areas that John talked about or Rod mentioned, where we're actually doing research on, or applied assessments in our case. We don't actually do any base research. That's done by all the smart people in this room. We do technology assessments to see how do we take all this good stuff, and our first speaker mentioned it, what's the so what of it? How do we take all this good stuff that people are learning about and apply it to our customers? So in our case, as I said, we're a public or investor-owned utility, but we're regulated by the state of California, and we cover a huge area. So this over here is our service territory, about a third of the state, and it has about 15 million residents. So when we look at a technology or a solution, we're trying to figure out, what can we do for residential customers and homes, for industrial infrastructure customers, for commercial, retail, and all that. So it's a big challenge. There's a lot going on. We also have a big challenge ahead, and I'll show you in a second. But today, we've made a lot of progress compared to a few years ago. Today, we already get over 40% of our energy from carbon-free sources, so renewables mainly, including hydroelectric, but a lot of solar and wind, and that number is increasingly rapidly over the next few years. So, our company has very similar goals to some of those you saw in the earlier slide. We need to continue to clean the power grid out there in the power system. We need to modernize that grid so it can do a lot of things differently tomorrow than it used to, including the ability to handle things like millions of electric vehicles. So we had mention here of, today we see a fair number of EVs out on the road. You're going to see a lot more in 10 years. So we have a goal upwards of you'll see about 7 million electric vehicles just on light vehicle cars, not counting heavy to medium or heavy duty transport. When we start talking about electrifying medium and heavy duty transport, buses, trucks, and port equipment, then the electrical load will go way up, and it'll have a much bigger impact on our carbon too. We also, in my area, our main focus is right here, working on our customer side. So we're a big company. Like all big companies, we have somewhat of a bureaucracy, but we try to work together. So there's actually two teams within Southern Cal Edison that does this type of technology assessment work. My team is on the customer side, so we look at technologies, products, services that are on the customer side of the meter in the home or in the business. There's an equivalent group to mine on our grid side, on our transmission distribution side, that's looking at the same question for things that apply directly to the grid and how do we manage that. So here's a chart, probably looks pretty familiar. John was showing you some global numbers. Ours are more focused down to California because that's where we do our business. In California, we have the same issue though. We're a little better in some ways. California, if you remember the chart that John showed you with energy efficiency, California has been very successful at keeping our just like the U.S. as a whole, California has been the leader at keeping our energy efficiency or our energy use per capita at a much better level than most places. However, having said that, we still got a huge goal ahead of us. So this is a stack chart showing, the main components. Sometimes it's, obviously in California, you don't get too far without dealing with transportation, electrifying our transport fleet or cleaning up our transport fleet. Of course, we have large industrial infrastructure. Here's power generation. And then, what we use today in our homes and businesses isn't that high a percentage, but then when you think about it, we have 30 million people in California, so that's a big number. We also have a significant agriculture infrastructure here in California, really helps drive our economy, and that we can't ignore that either. So our company 2 years ago came up with a plan, kind of our so-called clean power pathway. How do we support all these state goals, and how do we act as a model that can be used across the country as well? So it's a way to reduce carbon, try to modernize our grid, and help the customers without, and if you go back to the first speaker saying you can't do this if it's too terribly expensive, you can't dump the problems on people in terms of very high costs and bills. So the hardest part of these challenges is always the cost efficiency that we heard mentioned. So here's a view of our version of that little graph. If you look at a amount of carbon, CO2 emissions in this case in California in 1990 levels, we've been pretty good. We stayed pretty flat despite the state population increasing and our economy growing. Here we are now, and we have a goal down significantly low. So we have a structured goal here of 40% by the year 2030 and 80% reduction by the year 2050. You say, great, 2030, that's a long ways out, right? Well, so as we just heard a minute ago, the clock is ticking. That's, in our case, less than 11 years. We got to do an awful lot of things in 11 years. So here's where it breaks out for us. Probably looks pretty familiar to the charts you saw in the other speakers. Electric power generation and cleaning the grid is a big part of it. That's going to require more solar, more wind, and more storage to help balance it all out. There may be other methods too, but those are going to be the main drivers to continue cleaning the grid. We don't use coal in California anymore. Our coal exposure has been greatly reduced, but we still use lots of natural gas, and we will continue to do so, but we need to clean that grid up. Transportation, as I said, is a big chunk here. We have 30-some million people. We also have, I think, 20-some million registered vehicles in California. We also have the largest port complex in the country, and there's a tremendous amount of emissions from all that movement of goods in and out of California. Residential, commercial, all the energy we use every day, working and living and going to school. Industrial, California is a big industry state. And then agriculture, as we mentioned earlier. So the total goal, depends on your sector. We don't deal in all sectors. Our team that I work with, we're focused on the consumer side, which tends to reside in here and a little bit in here for the customers. So here's our three main pieces. As I said, as a company, we're looking to continue cleaning the power grid. We're looking to electrify as much of the transport as we can, and we're looking to electrify buildings and do other types of work related to that. So for us, most of it's energy efficiency related. We don't look at generation. Our company doesn't do generation anymore. In California, the regulated utilities divested themselves from the generation side of the business a number of years ago, and private sector does that, and as we said a minute ago, most of that growth is in clean, renewable solar anyway. So what do we do? Why are we so focused about it? New technologies? Well, for obvious reasons. Our utility grids have to do a lot more than they used to. Our customers are you, me. We're used to a lot of choices. I can do anything on my phone nowadays. I can have tremendous choices as a consumer. They want the same thing from our utilities too. Technologies, you saw the John slides. The results the technologies get today are so much more advanced in a short period of time than they used to be that we're trying hard to keep up. Our grid and our customers are seeing a lot more distributed resources, solar and wind, as well as new ones coming along. We always have cost pressures. We always want to try to keep people's cost levels down. So, as a utility, we don't have large staffs of researchers or scientists. How do we learn what we need to do? Well, we try to look at the tech market. In California, we have formal programs like this one called Emerging Technologies, where we're looking to identify technologies that are starting but have not yet made a good impact on the market. It may be that there are questions on the performance. It may be there are ways to get it to there are other barriers to get it to the customer, and we have to help do that. In our case, we use third parties a lot, and third parties, I'll show you, can mean anything from. So lots of entrepreneurs and startup firms. We're a member of a number of organizations where we get a chance to identify early stage companies or learn about new technologies and through startups and competitions. We help sponsor some startup competitions, tech developers that we work with a lot. Of course, our partnerships here with people like UCSB. We have structured partnerships with about 9 universities, as well as a number of UCs, also a couple out of state. We also have arrangements with a couple of the national labs like the NREL and Lawrence Berkeley Labs. We work closely with manufacturers. This is an area where it's not as well known, I think, but we have arrangements with a lot of manufacturers where we'll talk to them, we'll look at their technology roadmaps and what do they have and what will they be working on. They get feedback from us on where we think we would like to see coming up in the future. And of course, then, getting rubber on the road, engineering firms and consultants. So in our case, we have 2 programs. As I said earlier, we don't look at generation, partially because the way we're structured and funded. Our programs are funded here in alignment with this institute around energy efficiency. We also have a related one, demand response, where we're looking for ways to either reduce or shift the use of energy at a given time. Today, a lot of our projects have both of these. We combine both of them together. And we do that through different ways to assess and validate technologies. Our most common are these 3. We do demonstrations either in laboratories or in the field at customer facilities. We have a large number of them at either customer homes or businesses. Sometimes we scale them up to a number of installations, and then we'll do our technology showcases to sort of share with what we do. So I'm going to skip that one. You guys, probably most of you know this. This is a classic technology adoption description. You have an adoption curve here. When a technology is new, it follows a pretty well-known path of adoption. In our case, this infrastructure, basic research and applied research is done by people like you. You're going to come up with a new idea, you're going to put it together, you're going to try to get it to a certain point. When that starts to go to the market where people are trying to commercialize something, our programs are the ones that are designed to help people get that product or technology to market faster. At some point, if it's successful, it's going to get up here to mass market scale. So we're sort of operating in this, what we call the mid-stage in this area here, working with innovators and on our customer side, the early adopters as well. So same idea here. This is a technology adoption curve. If you look at over time, any new technology, if it's good, eventually the market will adopt it. It may take a long time. If there's something that we're excited about, we think has benefits to society or the grid or the company or consumers, we want to speed that up. So the traditional way to do that, if you look at this green curve, is you offer incentives. We pay rebates. We help drive the adoption of solar in California with over $1.5 billion of rebates. Some people forget that, but it takes a lot of money sometimes to give a hard shove. Later on, we did that with LED lighting. There was a lot of rebates paid on LED lighting. Today, we're doing the same on storage, for example. This is, what we're doing here. We're trying to speed up the adoption. We're trying to pull back the time curve by getting adoption to happen more quickly through these interventions. We build technology maps in-house where we look at all these different technologies we've been talking about today and said which ones are most impactful, which ones will help us get to where we're going, and how do we help that. So we break them out, just like John showed you in the Institute's case, we break them out into technology areas. A lot of them are very similar. You probably recognize them. Here's some of our main groupings that we use when we do our technology mapping. We do lighting and controls, refrigeration, air conditioning, cooling, water and agriculture, again, a big deal. Industrial process loads, which is under recognized, I think, by a lot of people, but industry uses a huge amount of energy for both manufacturing and other types of process, including food processing. Whole buildings or smart buildings, as John mentioned, and then plug loads, set-top boxes, that DVR that's using up all the energy in your house. We take those and we break them out further and we say, well, where is it at today? Where do we think it could be and what would we like to see and how long might that be? Is that a 3-year, a 5-year, or longer time frame. What are some of the drivers today? What are the barriers? Why aren't our customers adopting it? What do we need to do with that technology? And then how does that align with some of our goals, maybe our state goals, et cetera? And how do we get there? Who are we going to work with? Are we going to work with tech startup companies or UCSB or somebody like that? When we develop our tech roadmaps, we try to go outside the company to get as much information as we can for others. So we do peer review from outside organizations. Here's NRDC, who you saw referenced earlier, US DOE, and then other institutes in California and other nationally. We take all that information, then we share it publicly. This is publicly funded work that we do through our ratepayers, so we share that through a statewide process. We have websites, we have seminars and webinars, we have conferences and workshops, things like that. So the idea is when we learn something about a technology, we want to share it with people because then someone's going to take that and make some use out of it. Here was an example we were talking about earlier. Demand response, not as well known as energy efficiency, but it's been around for years, and our traditional method of demand response would be, we would send a signal to some equipment at a customer facility, and we would drop the energy usage for a period of time. Today it's gotten a lot more sophisticated, and we're looking at different methods of demand response here, in particular shifting energy. So as we mentioned earlier, in California we have a good situation now where we have huge amounts of solar energy being generated in the middle of the day, but our energy usage is actually lower at that point. So we've gotten to the bizarre, truly bizarre, if anybody's over a certain age in this room can remember, truly bizarre point where in the middle of the day we have energy that's so cheap people will pay you to take it. So one of our big challenges is how do we shift energy usage to that period? So a classic opportunity here is electric vehicles, right? If we have 7 million electric vehicles or 500,000 electric trucks and we need to charge them all, it'd be great if we could get some of those charged in the middle of the day when energy is cheap and available, and not charge them at 6 o'clock when everybody pulls home and plugs it into their driveway. Same thing is true for building energy usage. Maybe it's through thermal storage or other types of energy storage. Same thing for other opportunities like that. Building electrification is a phrase that John mentioned you probably haven't heard as much about, but the industry and the utilities and the policymakers are looking at ways to electrify a lot of processes we do today, whether it be heating and cooling or industrial processes, and take that opportunity to shift the energy use at the same time. So a simple example might be your water heater at home. If you have a gas water heater or you have even an electric resistance water heater, there are newer technologies like a heat pump technology where we could take that energy and we could shift the period of time when we use it, heat the water up at a different time, and still be available for when you want to use it. So I have a last couple slides here, a few examples of some of the projects we're working on. Here's an example, one that would be under the industrial process or also the efficient building, such as John talked about. This is incredibly boring, but in California we have millions of units of air conditioning or refrigeration or cooling. So every time you walk into a grocery store or you walk into a bar or restaurant, there's cooling at work there keeping that product cold. And all of those use a large amount of energy. On a larger scale, chillers for that often use cooling towers. Cooling towers are ugly things that sit up on the roof and you don't see them, but they're taking energy and they're also using water. And in California, water is a problem. So we have research going on and some projects going on where we're assessing some advanced technologies in that area that allow us to improve the overall cooling system efficiency, so it'll use less energy to keep the building or the food as cold as it is. It'll reduce the amount of chemicals that are being used because you have to treat the water to keep it from fouling the systems. And then you can sometimes save large amounts of water or divert it for other reasons. So we have active projects like this at a medical center, at a large hospitality hotel type company, and at a large biotech firm. and the results so far are very promising. So you see numbers like this down here. You can increase cooling system 5 to 6%. Sounds kind of boring, right? Except when you look at the amount of energy that system uses, it's a big number. Even more important, people's eyes light up. If you're the facility manager and you find out you could reduce your chemical use by 40 to 50% or your water use by 40% or more, that's a really dramatic number. Here's an example of something John mentioned earlier. We were doing research on what are called alternate refrigerants. So again, boring topic, but millions of tons of refrigeration around the country, or in California, we use refrigerants to cool things. Unfortunately, those refrigerants leak all the time, and they impact the atmosphere, and they're a global warming gas. So some of them are very high levels of global warming, and so there's a number of research areas focused on alternate methods of refrigeration that'll get the same or better efficiency. Here's an example of a large food storage warehouse down in Southern California, where we used a method called low-charge ammonia. Low-charge ammonia is more energy efficient. It's saving the customer energy on their bill. It's also reducing the global warming potential of the refrigerant that inevitably leaks out over time. Also has some other advantages too, takes up less space. I think our first speaker mentioned this too. Man, we connected well, didn't we? I didn't know that, but we recently started a new project around the idea of smart speaker. As you heard, lots of people have Amazons and Googles and Apple devices in their homes. These things are not only taking up energy, but they have the potential for us to help save energy through other methods too. So we're looking at ways that we can communicate through energy management hubs and things like that to devices in the home to help the customer make smart decisions that'll save them money, which is what they're going to be most excited about, but it'll also save energy. It also allows us to get insights on the behavior, and kind of the trickiest part of all this, as you also heard earlier, there's this, technology works fabulous, there's great things coming out of labs, but there's always this pesky human behavior aspect. So the human interface on a lot of this technology is really the hardest thing to figure out. And so some of our projects have an element like that where we're trying to figure out how does the customer react, what would be the drivers to make them do things. New building technology. Henley Hall, you heard about over here. In California, we still build homes. We don't build a lot of them, but they're on the order of 50,000 or more homes a year, and particularly multi-family homes. So here's an example where we're working with builders who put in new all-electric multifamily homes where you're looking at electrification of devices in there, going to the real basics, maybe the most overlooked part. You want to make them ultra energy efficient through the building envelope. The less energy you use overall, the better off. So these have solar, they have battery storage, they have EV charging, but they also have some other advanced features to make them smart homes. And then the last one here, we're doing a number of projects, quite a few, at this point around this idea of electrification. How do we electrify some traditional uses of energy like water heating up here and heating and cooling, and what are all the different applications for residential, for commercial, for multifamily, for retail, things like that. So a lot of work in those areas. I think this is my last one. Similar here, there's some new all-electric homes where we're trying to bundle all the offerings together and then do a lot of performance monitoring and other type of monitoring to understand how well they work together. So, you see lots of things from electric induction cooktops to those heat pump water heaters and heat pump space conditioning, but also ones that people don't really think much about, like high-performance windows or building envelope windows and attics, some smart voice energy management systems through smart speakers, and then things like the EV charger. And the trick here is, again, trying to get it all to communicate through integrated controls so everything's talking together and things are being used at the same time. So that's sort of examples of the type of work we're doing. We have about 100 projects or more going on at this point. We have my colleague, by the way, sitting here, Edwin's, this is IEE's 10-year. We've been doing this a little longer than that, but my colleague Edwin manages our EE program here for this research tech, or this emerging tech, and He's been doing it for over 10 years. And I would say today, he and I were looking yesterday, we have about 30 new projects coming out this year alone. So a lot of work, a lot of new activities. So that's it. We're out of time. Do we have any questions?